Hey Huskies, welcome to section 2.4. This is a preview of transformations functions, and we're talking about shifting. Today, there are three objectives that we're looking at here. We're learning about vertical and horizontal shifts, moving up and down. We're going to apply these concepts to real-world problems, and we're going to know the inside and outside function types of changes to a function. So if we change the inside number or the outside number, what does that actually do to the meaning of our function? So let's go ahead and get started. And so we're going to be talking about right into a vertical shift with a real life example. So to save money, an office building is kept warm by only during business hours. So figure 2.2.3 shows the temperature H in Fahrenheit as the function of time T in hours after midnight. At midnight, T equals 0. The building's temperature is 50 degrees, so there's a starting amount there. This temperature is maintained until 4 a.m. Then the building begins to warm up, so by 8 a.m. the temperature is 70 degrees. At 4 p.m. the building begins to cool. By 8 p.m. the temperature is again 50 degrees. So here's this nice graph that they use to explain that. So if we're looking at this and kind of looking, so remember from 12 to 4 a.m., right, there's a constant 50 degree temperature. It's turned off, and then they increase from 4 to 8 p.m. to get that building to a nice comfortable temperature, and then they keep that maintained for, I believe, the rest of that day, and then again that temperature starts to drop when nobody is in, and so by that 20th hour I'm guessing that would be back to midnight, and that same cycle would continue. So then it flatlines for those 4 hours there at the end. Okay, so here's our nice graph of what's happening in that real world situation. So let's look at what they're asking us here. So we're going to use that graph. It says, example 1 continued. What is the relationship between the function, the original heating schedule, and P of T, the new heating schedule? Okay. And so if we look under here, it says, suppose that the building superintendent decides to keep the building 5 degrees warmer than before. Sketch a new graph of the function. So we're going to end up doing that. Okay, so what's the new relationship? Well, we have this new temperature now. Okay, our new temperature is the original function, and remember the building manager decided to increase that by 5 degrees. So there's the new relationship. You're taking your temperature, your original temperature map, and you're increasing it by 5 degrees. So it's going to be a shift up. Okay, at the 6th hour, find the temperature in the building. Okay, so in this case they want P of 6, the new function. So P of 6 is going to equal F of T plus that 5 degrees. So it's P of 6 is going to equal F of 6 plus 5 degrees. So let's go back up to our graph and find the 6th. Okay, so the 6th is right about there. And I think I can draw a pretty straight line. It looks about 60 degrees. Okay, so that's what we're going to use for 6. So that's 60 degrees from our table, right? And we're going to add 5 to that. So the new temperature is 65 degrees Fahrenheit. That's our new temperature at the 6th hour. Okay, so that would be 6 a.m., right? Because the 0 hour is 12 a.m. and just add 6 to that. Part C, find Q of T, the formula for heating the heating schedule if at each time the temperature is 2 degrees lower than the original temperature. So 2 degrees lower, we have a new function. It's going to be Q of T is equal to F of T minus 2 degrees cooler. Okay, so that takes care of the first example. We're going to end up regraphing this later on when we get to example 2. So if you have any questions or comments about example 1, go ahead and type them below, and we'll see you next time for video number 2 on example 2.